Hey everyone and welcome. Today, we're going to pull back the curtain on one of the most important pieces of internet infrastructure that you've probably never even thought about. We're talking about load balancers, the unseen heroes that quietly keep your favorite apps and websites running smoothly.
You know the feeling, right? There's a huge sale, a big product drop, whatever it is. You're frantically refreshing the page, trying to check out, and then, boom, the site just grinds to a halt and crashes. It's so frustrating. Well, that exact experience is the problem we're here to solve today.
So, what's really happening during that crash? You're stuck in a digital traffic jam. And a lot of the time, the root cause is surprisingly simple. A single server trying to handle way too much traffic. This approach has two massive, glaring weaknesses. First, it gets overloaded. A server can only handle so many requests at once before it gets overwhelmed and just gives up. And second, it's what we call a single point of failure. If that one server goes down for any reason, a power outage, a hardware failure, anything, the entire website is gone, kaput. Now, there are a couple of ways to deal with this. You could try a vertical scaling, which is basically just buying a bigger, beefier, more powerful server. But you eventually hit a wall. There's a limit to how big a single machine can get. The much more powerful and common approach is horizontal scaling. Instead of one giant server, you just add more servers, a whole team of them. But this creates a brand new problem, right? How do you decide which of these many servers should handle the next person who shows up?
And this is where our hero finally enters the scene, the load balancer. Seriously, the best way to think about it is as the internet's traffic cop, or maybe an air traffic controller for data. It stands in front of that whole group of servers, looks at all the incoming traffic, and tells every single request exactly where to go.
So here's the official definition. A load balancer is an intermediary. Its entire job is to sit between you, the user, and the pool of servers. It takes that constant flood of requests and intelligently spreads them out. The goal? To make sure no single server gets buried in work, which keeps everything fast, efficient, and, most importantly, reliable.
Okay, so let's get into the nitty-gritty. How does this traffic cop actually work its magic? What does the journey of your browser's request actually look like when there's a load balancer in the picture?
So it all starts when you type in, say, website.com. But here's the trick. The Internet's address book, the DNS, doesn't give you the IP address of the actual web server. No, it gives you the address of the load balancer. So your computer connects directly to it and only it. The load balancer then looks at its team of servers, picks the best one for the job, and passes your request along. That server does its work, sends the web page back to the load balancer, which then forwards it right back to you. The key takeaway here is that you, the user, are completely unaware of the complex army of servers working behind the scenes. You only ever talk to the traffic cop.
But that's the big question, right? How does it actually choose? Is it just random? Is it picking a favorite? No way. There's real intelligence behind that decision. The load balancer uses a specific strategy, or what we call an algorithm, to make the smartest choice every single time.
And there are a few common ways it does this. The simplest is round robin. This is literally like dealing a deck of cards. The first request goes to server 1, the second to server 2, the third to server 3, and then it circles back to the start. A smarter method is least connections. This is like picking the shortest line at the grocery store. The load balancer checks which server is the least busy at that exact moment and sends the new request there. And then there's IP hash. This one makes sure that all requests from you consistently go to the same server. That's super important for things like keeping items in your online shopping cart.
Now, it's also worth knowing that not all load balancers are the same. They generally come in two main flavors, software and hardware. And choosing the right one really depends on what you're trying to build.
You can think of it as a classic trade-off, flexibility versus raw power. A software load balancer is just an application you can install on a standard server. This makes it super flexible, easy to customize, and you can scale it up or down pretty easily. On the other hand, a hardware load balancer is a dedicated physical box. It's a specialized piece of equipment built to do one thing and one thing only: direct traffic at insane speeds. They are way more expensive and not as flexible, but if you need the absolute best performance possible, this is the way to go. Okay, we've gone through a lot of the technical stuff, how it works, the different types, but let's zoom back out. Why does any of this actually matter to you when you're just trying to watch a video or buy something online? What's the real impact on your day-to-day web experience?
Well, it matters because it's the reason the modern internet actually works. You get high availability, which means if one server randomly dies, the load balancer just stops sending traffic there. The website stays up and you probably never even knew there was a problem. You get scalability, which is how websites survive those massive traffic spikes during a big sale. They just add more servers to the group. This all leads to just plain better performance and reliability. The system even performs health checks to make sure servers are okay. It even allows for things like seamless updates, where engineers can take servers down one by one to update them without ever taking the whole site offline. It all adds up to a faster, more stable web for all of us.
And this quote right here just nails it. It really gets to the core of why load balancers are so elegant. They provide this beautiful, simple layer of abstraction. We, the users, just need to know one single address. Behind that address could be 5 servers or 5,000 servers. We don't need to know or care. The load balancer handles all that complexity for us.
So that brings us to one final thought. Load balancers have been an incredible solution for managing the traffic of our current internet. But as our digital world just keeps getting bigger and more complex, with more devices, more data, more everything, you have to wonder, what new unforeseen traffic jams are on the horizon? And what kind of even smarter, more advanced solutions are we going to need to invent to handle them? Thanks for tuning in.